difference between exothermic and endothermic reactions. First, we're going to start with endothermic. Where energy is transferred from the surroundings to the system. Okay, and this is breaking bonds. So delta H is going to be positive. So the reaction is going to physically feel cold to us because energy is being absorbed into the reaction. Okay, then our energy profile graph is going to look like this, where this is delta H. And delta H is going to be positive. And this is the breaking of bonds, and this is the making of bonds. And making of bonds still happens, just the breaking is larger than the making of bonds. Okay? Two examples of this is going from a solid to a liquid, or a liquid to a gas, because you're breaking those bonds. And then the second example is melting ice, which confuses a lot of people, but if you think about it, you're going from a solid to a liquid. Okay. Now we're going to learn about exothermic reactions. Where energy is transferred from the system to the surroundings. And this is making bonds. So our delta H is going to be negative. Okay, energy is being released during this reaction, so the container of the reaction is going to physically feel hot to us. Okay, and energy profile graph is going to look like that, where this is the breaking of bonds and this is the making of bonds. But we make more bonds than we break. So that's why delta H is going to be negative. Okay. Two examples include an equation like this where heat is being released. Another example is the freezing of water, because you're going from a liquid to a solid, and that's making bonds. And exothermic is usually thermodynamically favored because most reactions are going to be exothermic opposed to endothermic. Now pause the video and determine whether these problems are endothermic or exothermic. Okay, number one is going to be endothermic, because you're going from a solid to a liquid and you're breaking those bonds. Okay, number two is going to be exothermic, because on the chart we determined earlier, your delta H was going to be negative. Okay, this energy profile graph, this is the breaking of bonds and this is the making of bonds, and since the making is greater than the breaking, it's going to also be exothermic. And you can also look at this from looking at the delta H, and that's going to be negative. The last one's going to be endothermic, because heat is being absorbed in the reaction.